Hi learners! In today's video lesson, you will learn how to determine the total surface area of right triangular prisms. Determining the surface area is demonstrated and explained in details to let you understand the concept easily. Real-life applications of the surface area of triangular prisms are shown, thus making the concept relatable and meaningful. Strategies in analyzing and solving problems related to the topic are demonstrated to let you gain an understanding on how these are done so that you'll be able to successfully answer geometry problems similar to this in the future. If your lesson is on solid geometry, particularly on surface area of right triangular prisms, or if you have an assignment on this topic, or if you are preparing for a test in math or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. In an earlier video, we described a triangular prism as a solid or 3D object having 3 lateral rectangular faces and 2 parallel and congruent triangular bases as shown. On this video lesson, we will only consider right triangular prisms. These are the triangular prisms that are upright when sitting on their bases, like what we have here. But a triangular prism is not always sitting on its base. In fact, most of the real-life examples of triangular prisms are sitting on one of their lateral faces like rooftops, camping tents, triangular rulers, Toblerone wrappers, etc. How do we know that you have a right triangle prism if positioned this way? All you need to do is to check if the lateral rectangular face forms a right angle with the triangular bases. If they do, then you have a right triangular prism. Our goal today is to find the total surface area, TSA in short, of right triangular prisms. Let us consider this right triangular prism with a right angle on its base. Imagine that the triangular prism is an empty container. Opening the container shows us its 5 surfaces, the 3 lateral faces, and the 2 bases. This is the 2D shape of the triangular prism. We call this a net. A net is a 2D shape of the 3D object. How do we find the area of our 2D shape? Just like what we did in an earlier video lesson, we will make the shapes that are here simpler and smaller in number. Now, we only see 3 shapes, correct? We have a large rectangle, the 3 lateral faces, and 2 congruent triangles, the 2 bases. Let us label the horizontal as the length and the vertical as the width of the rectangle. With this, the area of the rectangle is length times width. Now let us look at our triangular prism again, the 3D object. Isn't it that the length in our rectangle is the perimeter of the triangular base in our prism, and the width is the distance between the 2 triangular bases? This leads us to the formula for the surface area of the lateral rectangular faces of the triangular prism, which is the perimeter of the triangular base times the distance between the triangular bases. Let us call the sides of the triangular base as A, B, and C, and the distance between the triangular bases as D. Since the perimeter is the sum of the length of the sides of the triangular base, the surface area of the 3 lateral faces of the triangular prism is now the sum of A, B, and C times D, where A, B, and C are the sides of the triangular bases, and D is the distance between the 2 triangular bases. Remember that there are still 2 congruent triangular bases. Our triangle is right, so the area of one triangle is just half the area of a rectangle, which is 1/2 A times B. Since there are two of these triangles representing the bases, the surface area of the two bases is therefore twice the area of the triangle. Canceling 2, we have the surface area of the two right triangular bases, which is A times B. Now, to get the total surface area, or T is A in short, of the triangular prism, we simply add the surface area of the three lateral faces and the two bases. Plugging in the expression for the surface area of the lateral faces and the surface area of the two bases gives us the total surface area of the triangular prism, which is the sum of A, B, and C times D plus A times B, where A, B, C are the sides of the triangular bases and D is the distance between the two triangular bases. Now, being an area, its unit of measure is in square units, like square centimeters, square meters, square feet, etc. There you are, learners. I hope you were able to follow. As what I mentioned in an earlier video, sometimes our problem will just ask for a portion of the total surface area and not the total surface area. So when working on a word problem, read the problem carefully and read it several times when needed to know what the problem is really asking you to look for. Okay, so let us do this sample problem. Here's the problem. Nelson acquired a piece of wood with the shape of a right triangular prism. He intends to display the piece, so he asked his artist friend to paint the entire piece with varied themes. What is the area of the entire wood that will be painted? Option A, 63 square feet. Option B, 67 square feet. Option C, 71 square feet. Option D, 79 square feet. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What is asked in the problem, learners? Okay, here we are asked to find the area of the entire wood that will be painted. What are given? We're given a figure of the piece of wood having the shape of a right triangular prism with dimensions. Now, the problem states that the piece of wood has the shape of a right triangular prism. Thus, getting the area of the entire wood to be painted with that shape is like getting the total surface area of the triangular prism. Do you agree, learners? So here, we start by having the formula for the total surface area of the triangular prism, which is surface area of the lateral faces plus the surface area of the bases, which is further broken down into the sum of A, B, and C times D plus A times B. Let us identify what each measurement in the figure represents so we can easily plug in the values into the formula. Let's go. Plugging in the values, we have 2 feet plus 4 feet plus 4.5 feet times 6 feet plus 2 feet times 4 feet. Adding 2 feet, 4 feet, and 4.5 feet gives us 10.5 feet. Multiplying 2 feet and 4 feet gives us 8 square feet. Multiplying 10.5 feet and 6 feet gives us 63 square feet. Adding 63 square feet and 8 square feet gives us 71 square feet. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option C. Therefore, the area of the entire wood that will be painted is 71 square feet. That was easy. Let us move on to sample problem 2. Here's the problem. The Nadal family wants to make an A-frame tent without a floor. They have a mat that will serve as the floor. Their tent will have the dimensions shown. For the material, the family will use a waterproof canvas fabric. How large of the fabric will be used for the tent? Write your answer to the nearest tenth of a square feet. Option A, 142.6 square feet. Option B, 163.6 square feet. Option C, 169.6 square feet. Option D, 211.6 square feet. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What is asked in the problem, learners? Here, we are asked to find how large of the fabric material will be used in making the tent. What are given? We're given the figure of the tent with its dimensions. Okay, so the tent that the Nadal family wants to make has an A-frame design. This has the two faces of the roof and the front and back triangular surfaces. The design does not include a floor. This shape is similar to a triangular prism with the absence of one lateral face, the face where the tent is sitting on, the ground. Because it has the shape of the triangular prism, we will use here the formula for the total surface area of the triangular prism in solving the problem. Let us have again the formula. What we will do is solve first for the area of the lateral faces, the roof, then solve for the area of the two triangular surfaces, which are the front and back surfaces of the tent, then combine the two results. Okay, let us further examine the diagram of the tent that we have here. What can you say about the sides of the triangular front of the tent? You're correct. Since the tent has an A-frame design, the two sides of the triangle connected to the roof are equal in length. The third side, where the ground is shorter. Let us then label the other side of the triangle. Let us also identify what each measurement in the diagram represents so we can easily plug in the values into the formula later. Let's go. Now, this type of triangle, where two of its sides are equal in length, is an isosceles triangle. This is not a right triangular base, so we must practice extra caution in solving for the area of the triangular surfaces of the tent later. Okay, let us now solve for the surface area of the lateral rectangular faces. In our tent, these are the two faces of the roof. So the surface area of the lateral faces is A plus B plus C times D. Remember that the design does not contain a floor, so the perimeter of the triangular base will only have the values of A and C. The value of B is equal to 0. Can you follow, learners? Plugging in the values we have 7.6 feet plus 0 plus 7.6 feet times 8.0 feet. Adding 7.6 feet and 7.6 feet gives us 15.2 feet. Multiplying 15.2 feet and 8.0 feet gives us 121.6 square feet. So the fabric material needed for the roof of the tent having the two faces is 121.6 square feet. Now, we proceed by solving for the area of the front and back triangular surfaces of the tent. As mentioned earlier, we need to be careful in solving for the surface area of the triangular bases here, for they are not right triangles. Look at the triangular front surface again, learners. What do you see aside from the sides of the triangle? You're correct. You also have the height of the tent. The height of the tent is also the height of the triangular surface. You have to remember this, learners. This line, representing the height of the triangle, is perpendicular to the opposite side. Here, the area of the triangular base is 1/2 h times b. Since there are two of these triangular bases, the surface area of the two triangles is h times b, where h is the height of the triangle and b is the base of the triangle. In our tent, these are the front and back triangular surfaces. Plugging in the values, we have multiplying 7.0 feet and 6.0 feet gives us 42.0 square feet. This is the amount of fabric material needed for the two triangular surfaces of the tent, the front and back surfaces. To get the total amount of fabric needed for the tent, we use the formula for the total surface area, TSA, which is the surface area of the lateral faces plus the surface area of the bases. Remember that the surface area for the lateral faces is the amount of the fabric material needed for the roof of the tent. And the surface area for the bases is the amount of the fabric material needed for the two triangular surfaces of the tent. Plugging in the values we got earlier, we have 121.6 square feet plus 42.0 square feet. Adding 121.6 square feet and 42.0 square feet gives us 163.6 square feet. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option B. The fabric material needed by the Nalda family to make the tent is therefore 163.6 square feet. There you are, learners. That was again easy. Now, before we close this lesson, I would like you to remember this, learners. The area of a triangle is 1/2 the base times the height of the triangle. Or maybe you can say 1/2 the height times the base of the triangle. And multiplication is commutative, so you can interchange them. Here, the two line segments, the base and the height, are perpendicular each other. That is, a 90-degree angle is at the point of their intersection. In sample problem 1, where we have this triangular base, the area of the triangle is 1/2 a times b, where a and b are the sides of the triangle. More so, they are perpendicular each other. In this triangle, side A is at the same time the height of the triangle. In sample problem 2, where the triangular base has this shape, the area of the triangle is 1/2 h times b, where h is the height of the triangle and b is the base of the triangle. Observe that h is perpendicular to side B, the base, and not side A. Side A on this triangle is therefore not the same as side A on the previous triangle. Always remember that the height of a triangle is a line segment drawn from the vertex of the triangle at the top, perpendicular to the opposite side. The line segment representing the height of the triangle can be on the triangle, as in sample problem 1, inside the triangle, as in sample problem 2, or outside the triangle, as in this figure. Remember that the height is perpendicular to the base. There you are, learners. I hope that you acquired lots of learnings in today's video. That is summarized what we have learned today. We have learned that, first, a triangular prism is a solid or 3D object having 3 lateral rectangular faces and 2 parallel and congruent triangular bases. Second, the total surface area, or TSA in short, is the area occupied by the surfaces of a 3-dimensional object in square units, like square centimeters, square meters, square feet, etc. Third, the formula for the total surface area of a right triangular prism is the sum of the surface area of the lateral faces and the surface area of the bases. Fourth, if the triangular base is as shown, the surface area of its bases is A times B, and the total surface area of the triangular prism becomes the sum of A, B, and C times D plus A times B, where A, B, C are the sides of the triangular base, and D is the distance between the triangular bases. Fifth, if the triangular base is as shown, the surface area of its base is H times B, and the triangular surface area of the triangular prism becomes the sum of A, B, and C times D plus H times B, where A, B, C are the sides of the triangular base, and H the height of the triangular base, and D is the distance between the triangular bases. Sixth, when solving a problem, you must read it and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what you are looking for. Seventh, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any question, leave a comment below, and don't forget to like, subscribe, and share this video to your peers so others will learn too.